I am Jay Lesandrini. I'm the Director of Marketing for Axia Technology Partners. Josh couldn't make it, unfortunately. He got called away on business, so I'm going to step in and kind of take you through this presentation. Afterwards, Lucas Skipper's here. I'm not a tech guy, so I brought along our network engineer for the Chit Chat Lounge. So if you have any tech questions, he'll be with me in the Chit Chat Lounge to answer those types of things as well. If you don't know about Axia Technology Partners, we're here in Indianapolis. We're over in the Gold Building. What we do is we do IP technology solutions. So we provide business internet service, voice over IP phone service, managed services, network routers, switches, firewalls, that type of stuff. So one of the things that happens is when we go out and talk to clients, we tend to find out that they don't quite understand. They want to put all the new technology that's available from Web 3.0 into their business, but they don't understand that they might need to upgrade or what's actually driving that from the bottom end. So I want to talk a little bit in 30 minutes, probably a little 5,000 to 10,000 foot view about some of the things in terms that you need to know or will want to know as you move forward. If you're not a tech guy, hopefully it gives you some information that'll help you know what questions to ask the tech guy. If you are a tech guy, I'm hoping I'm going to give you some language that you can use when you're talking to the non-tech people to kind of help them understand what it is that they need to know. If I were to retitle this or have a subtitle for it, I would say, what you don't know can hurt you. And what I want to say is IP technology provides that backbone that enables things like internal and external communication, increased productivity, optimized workflows, collaboration, both internally and externally, as well as innovation. And if you imagine that your business is this building here, at the penthouse you have all these web applications, these productivity suites, Office 365, or maybe if you're a civil engineer, an architect, you use Fusion or Fusion 360 from Autodesk. Sales and marketing, you've got Marketo and Salesforce and all these web-based tools up here that you want to use, but they rely on technology that sits below it. The one thing we forget, too, is that we've got these technologies that have been around for a while, our internet, an intranet, maybe a phone system or a phone service that are layered in there as well on your business. And then below that, what drives everything are these foundational technologies. And that's going to be your local area network, a wide area network, and maybe some network hardware and services, or hardware and software and managed services. So that's kind of where I'm going to focus today is more on the foundational stuff. I'm going to talk a little bit about some of the web applications, but mainly on the foundational technology. I want to level set, brief history of the web for those who don't remember. It started roughly, it started before this, obviously, but 1990 to 2000 is this Web 1.0. If you were there, you remember it, there were static websites, there was one-way communication. Businesses basically scanned their brochures and threw them up on the web, put some hyperlinks in there, and that was it. There were bulletin boards. That was two-way communication, right? It was a bulletin board. Somebody posted something, and somebody else posted something, and they both read it. You can see some of the companies there that were available, and down low you don't see, but it was low bandwidth requirements at that point, right? We were still using our telephones with modems to do that. Web 2.0 comes along with the kind of the internet, the whole bubble. We start with two-way communication, and what that allowed is things like social media and wikis and e-commerce, and you can see some of the players that come into play there. You've got Google and Amazon, Facebook, brought the rise of broadband. Web 3.0 comes along, and now all of a sudden we got this always on, right? It's always there, it's always on, it's data-driven, everything is going to be, as we get toward 2020, your phone, your everything, you're just a walking data bit sitting out there in the ethersphere. So we've got things like the Internet of Things. I've got a smartwatch. I got one for Christmas. It's connected to my phone. If I had a refrigerator at home that was smart, it would probably be telling me I need some milk on the way home. But everything's connected. It also enabled the cloud applications as well. And that's kind of where what we see is people are wanting to add these cloud applications at the top end and not thinking about the fact that they've got this technology that they've been using for a number of years on the bottom end that may or may not support those technologies. In terms of broadband or in terms of the internet, fiber and gigabit speeds come into play. So, talk about the technologies. We start with the local area network. I'm going to go really simple. There's some servers. You might have some laptops and some desktops. You might have some printers and some other things connected, but all of this stays within your own building, and that's your local area network. You may be running it through maybe Wi-Fi or an Ethernet connection, but you can't just do business in your own building, so you have to go outside. You go to a wide area network. Most of the companies will have a firewall in there to protect themselves. From that, then you can go out. You might have a remote office. You might connect to like a data center, and then you get out to your internet service provider. And that's really the key. The internet service provider is the one that gets you to the cloud, right? So, what is the cloud? If we talk to 20 people, you ask 20 people, you're going to get probably 19 different answers, maybe 20. I tried to find kind of a general term for it. So what I came up with is cloud computing is a general term for the storage of data and delivery of hosted services over the internet. Pretty broad, pretty basic, but that's pretty much it. There's really three types of cloud in terms of that. So you've got a public cloud. Public clouds are run by third parties. It's a third-party owned. You would probably lease some space from them. It's shared hardware and service, so your stuff is going to be running on the same hardware as maybe some other company. And the big advantage is it's cost-effective. To put it into perspective, if you, from a personal standpoint, if you use iTunes, if you use Amazon Music, and you're storing your music up there, you're storing it on a public cloud. So from a more of a personal standpoint, that's how that works. That kind of explains what a public cloud might be. The opposite of that is private cloud, and those are going to be client-owned, so you're going to own that yourself. You're going to have dedicated hardware and software, and the big advantage is security and compliance. So that will enable you to have more security than the private cloud. It also enables you to do something called hybrid cloud, which is you might do a little bit of both. So you get a little cost savings over here on things by leasing some space. The more important things that you need to keep secured, you'd have in your private cloud. So let's go to the cloud, right? Talk about cloud-based apps. Productivity apps, you've got things like Office 365, Google Docs, maybe WebEx. These are the things. And when I talk about Office 365, this is something that is interesting. We work with Sandy Solutions, and they see this a lot too, which is you have a company and you decide, hey, we're going to just upgrade. We're going to upgrade to Office 365. And the thought process that doesn't happen is all of a sudden now, because that's in the cloud, we've got to write a lot more data up than we were before. And so if you're not thinking about those foundational technologies and what type of internet service you have and how much bandwidth you have going up, that could cause some problems down the road. From a design standpoint, I use Adobe Creative Cloud. I know I came from a design background as well. A lot of people are moving to Adobe Creative Cloud. Autodesk Fusion 360, they're probably, I don't know if there are any Autodesk people here. I worked a lot with Autodesk in a past life. They're moving to a cloud-based. If you can imagine that, writing files for Civil 3D, writing architectural files, it's a lot of data going up as well as down now than it was before. Sales and marketing tools, we're probably all familiar with these. Salesforce.com, Sugar, HubSpot, Right on Interactive. All of those things you're doing in the cloud. You're doing them browser-based. So you don't have a piece of software sitting on your desktop where you're doing those applications. And then lastly is the communication stuff, the voice over IP. Only about 27%, right, of businesses currently use voice over IP. So that's something that's going to trend up over time. If you're thinking about that, if you're thinking about moving to a voice over IP service, that's the time to go back and look and make sure you have the infrastructure to support that. So I want to talk a little bit about bandwidth and bandwidth requirements. We talked about this Web 1.0. You see a lot of data coming down, very little going up. 2.0 gets a little bit more. 3.0, even more, because now we've got a bunch of folks, get your phones and your tablets and all these BYOD devices connected on your network in the office as well. And I kind of see by the time we get to 2020, it's just going to be one kind of open pipe. So understanding bandwidth, and this is an area that I didn't really, until I started working for Axia Technology Partners, I didn't really get this either, which is bandwidth speed doesn't measure speed. It measures how much data you're going down a pipe. So if you can imagine you got this big pipe, and it's how much stuff you can stuff down it. It's not how fast it gets down the pipe. And that's kind of a misnomer. So it doesn't necessarily mean that if you increase, so if you have a pipe that's 25 megabits per second, and you're only shoving 15 megabits down it, and you say, I'm going to go to a gig speed, not really going to necessarily get you a whole lot more speed because you're not using all of that bandwidth anyway. Actual speed and performance is represented by latency. So if you use like a speed test or one of those things, what you'll see is there's a thing called ping rate, and you'll see that ping. Good ping, I've been talking to my engineering guys, is 30 to 50 milliseconds is actually a pretty good ping rate. I did this at ours. We have one, but then again, we provide our own internet service. So but the actual thing is represented by latency, and that's the amount of time it takes for data to travel from one point to another. So if you can imagine, if you're hitting a server in China, it's going to take a lot longer than if you're hitting a server in Cincinnati. And that's one of the things. But other things that can cause delays is internet congestion, and even to an extent, the routers and things that are along that path, if they're having trouble passing data, that's going to slow things down as well. So you can imagine just increasing the size of the pipe is not necessarily going to increase your performance. It's a part of it. If your pipe is too small and you're trying to shove too much data down it, obviously that's going to affect your performance. But if you've got enough bandwidth, there's these other things that will also cause issues. So at the end of the day, increasing the bandwidth may or may not enhance your performance. The other thing I'd like to talk about, and this is another thing that I didn't quite understand before I got to Axia Technology Partners, is the difference between shared and dedicated bandwidth. So when you're going out to get internet service, shared bandwidth is oversubscribed and throttled as needed by the ISP. I was talking with Josh yesterday, and he said that oversubscription rate is usually 14 to 18 times, right? So if you think about that, if the ISP has a pipe, and I'm just going to throw a hypothetical, it's 100 megabits per second, they're selling 18 times that amount to their customers. So if everybody's using it at once, everybody gets throttled back so that their traffic can get through, but they're not getting everything that they're paying for. And the reason is you'll see a thing called up to speeds, right? And that's a term. It's up to speeds. I get up to 25 megabits per second. So if nobody else is using it or a few people are using it, then you're going to get that full rate. It's asymmetrical, right? So you're going to get a different amount up than you get down. Right now, the FCC just changed the rule in 2015, or the definition of broadband in 2015, to make it 25 megabits down and 3 megabits up. It used to be, I think, 4 and 1, or 1.5, I think it was. And so one of the things that did, just as a side note from marketing, is you stop seeing people talk about broadband in a marketing standpoint. So you start seeing high-speed internet, business internet, all these other terms. Broadband kind of went away as a term because a lot of the business or a lot of the services that are out there don't meet this definition for broadband. So that's asymmetrical. The big advantages of the shared service is cost. And the fact of the matter is, for a lot of businesses, you may not need to have that dedicated bandwidth. That may be fine. If your performance is good and you're running and that cost is fine. So I'm not advocating one is better. I just want to give you the language and so that you understand what you're dealing with when you're looking at these various technologies. The opposite of that is dedicated service. And this means you own that pipe. So if it's 10 megabits, if it's 25 megabits, you own it and it's symmetrical. You get the same speeds going both ways. But I think the big advantage of dedicated service is that it enables class of service, or sometimes quality of service. And what that means is that at each end of the pipe, because you own that whole pipe, at each end of the pipe, the ISP puts some technology on there that provides them to be the ability to differentiate the types of traffic and assign priority. So if you have a call center, for instance, and it's March, and everybody turns on the NCAA championships, you could have technology on there that says, I want my voice traffic to have a priority, right? So when everybody starts streaming the basketball games, your voice traffic is still going to go through. And it's really, that to me is one of the heights or the big parts about dedicated service. The other thing you get are service level agreements. So they will provide you roughly, usually it's 99.99 or 99.999. What that means is they're going to get you back online if there's a problem, because they are incentivized to do that, because if they don't, they're going to pay a penalty to you. With shared bandwidth, generally it's a best effort. So they're going to get you back up as quickly as they can. They're going to give you good customer service, but it may take a little longer. The other thing to talk about, or the other thing to think about with this, is that when I talk about the class of service and the dedicated that comes into play, is that the potential is there that you don't need as much bandwidth if it's dedicated than you do when it's shared, obviously, because the shared is oversubscribed. So if you're looking at that, don't necessarily discount that as an option. It's going to be more expensive, but in the long run, it might not, because you may be able to throttle back the amount of bandwidth you're buying, and it may be a little bit closer, and you get some of these other advantages as well. Again, I'm not trying to say you should go shared or you should go dedicated, but take a look at it. It may be worth the look. Now I'm going to talk a little bit about marketing hype versus technology. And this is another kind of thing that we run into, which is there's a lot of terms out there, and they mean a lot of different things. Ultimately, I love this thing. going to pick a little bit on AT&T here because I just absolutely love it. I'm not picking on him, but I love this graphic because he's getting the gig service and he's so excited. We're all excited about gig speeds. We're actually an AT&T partner, so hopefully they won't be mad at me for that. And then the bottom one is just kind of some of the things. I grabbed that. I'm not sure where I grabbed that one from, but it's a little bit different. You'll see things like for residential service where you can download 4 movies in 20 seconds. I don't know why you'd want to download 4 movies in 20 seconds, but you can do all these great things. And the hype, and it gets you excited about that. And you're thinking, wow, it's just really going to be so much faster and so much better. But what you have to realize is there's technology behind that possibly could limit it. So say you get a gigabit and it's coming into your building. Well, it's probably going to hit a firewall. And a Cisco firewall, kind of a standard Cisco firewall, an ASA 5010 that is one of the ones that we tend to put in. It's 300 megabits per second, so immediately you've lost 2/3 of your bandwidth right there. That doesn't mean you can't upgrade, but you might need to. So you'd need to check to see what type of firewall you had to make sure that it could handle that gigabit. Then it's going to run into a switch. And the switch should be able to handle it. Most everybody should have Cat 5, Cat 6, or Cat 7 Ethernet cables, so you should be fine there. So your gigabit may get to the computers if you're using Ethernet. But then if you throw in a Wi-Fi router, now all of a sudden you got another issue because your Wi-Fi router might be 802.11n, which is 450 megabits per second, which would mean you'd need to upgrade that to an AC router. So say you upgrade that and you get that. Well, now all of a sudden you got all these, a little bit too far. You got all these computers that may be a little bit older too. So a lot of them might be N, but you may have a few people still running 802.11g. So your gigabit that's coming into your building is now 54 megabits per second by the time it gets to the people working. So those are just things to think about as you're moving forward, and I want to kind of throw that out there in terms of, do I need gigabit internet? You might, maybe not. Look at what your requirements are and what that is, because all that's going to do is get you a bigger pipe. And when you think about that, you think about how many people do I have and how much data do I need, not necessarily how much speed. So that's the time that you really would want to look at upgrading. So I think I'm finishing up. How am I doing on time? Actually, I'm way ahead. Back to this foundational idea. So as I'm going to kind of wind down a little bit, you've got all these services. You want to add all these new services to your company so that you can do more things. Make sure that you take the time to look at your foundational technologies, that you go back and you talk to the IT guys and that you say, hey, do we have enough bandwidth? Do we have the right hardware? Do we have those things? Because if you don't, you're going to add these types of products, you're not going to get the performance that you need, and what's going to happen is you're going to have to make a phone call. And the guy you're going to talk to is this guy. He's going to tell you it's not our fault. You got to talk to the other guy, right? And nobody wants to talk to this guy. So I maybe went a little fast. Did I talk too fast? I always talk fast. But that's kind of it. Lucas and I will be in the Chit Chat Lounge. I'm sure to walk the exhibit floor and talk to people. But thank you so much for your time. I appreciate it.